All right, today we're putting on our detective hats. We're going to hunt for a hidden culprit that can secretly sabotage your entire data analysis and lead you to some completely wrong conclusions. Let's start with a classic case file.
So take a look at this. It's a classic question for a reason. If you actually plot out ice cream sales and crime rates, you'll often see them move up and down together. It looks like a super clear connection, right? The more ice cream we eat, the more crime there is. But is that what's really going on here?
Yeah, you guessed it. Probably not. This is a textbook case of spurious correlation, a relationship that looks totally real but is just an illusion. Now, the obvious answer is the summer heat, right? But there's a deeper, more technical reason this kind of illusion happens. It's like a statistical ghost that haunts our data. And to find it, we first need to understand how data can trick us.
Okay, so this ghost, it doesn't just appear anywhere. It lives inside a very specific type of data. And to unmask it, we have to know the difference between two fundamental kinds of time series data, the ones that behave and the ones that deceive.
So on one side, you have what we call stationary data. Think of it like a really well-behaved dog on a leash. It might sniff around and wander a little bit, but it always comes back to you. Its average, its variance, all its statistical properties, they stay constant over time. It's predictable. But then you have non-stationary data. This is the dog that slipped its leash. It's just gone. It wanders off with no home base to return to, and its path is completely unpredictable. And this, my friends, is where all our problems begin.
This wandering behavior, this dog off the leash problem, actually has a formal name in statistics, and it's the very culprit we're hunting for today. It's called a unit root. A unit root is the statistical gremlin that causes this wandering, unpredictable path. To put it simply, it means that wherever the data is right now, well, its next step is going to be that same spot plus some random change. Because of this, any kind of shock or surprise doesn't just fade away, it gets permanently baked into the data's future. It's now part of its DNA.
So a unit root leaves behind some very specific fingerprints. First off, shocks are permanent. A surprise event doesn't just cause a temporary blip, it permanently changes where the data is headed forever. Second, its variance just keeps increasing over time. The data gets more and more spread out, more and more unpredictable. And third, it's non-mean reverting. It never feels that gravitational pull back to a long-term average. It just drifts.
Okay, so data can wander. Why is this such a big deal? I mean, who cares? Well, you should care, because this one little statistical feature can completely, and I mean completely, invalidate your entire model.
A unit root is basically a master saboteur. First, it causes that spurious regression we talked about, tricking you into seeing connections that just aren't there. Second, you get invalid t-statistics. This means your statistical tests will lie to you, making you think random noise is a massive, significant finding. Third, you'll get inefficient estimates, so your model's conclusions are wobbly and unreliable. And finally, all this leads to unreliable forecasting. Your predictions for the future, they become essentially useless.
And this quote, wow, it just gets right to the heart of the danger. You can find a statistically significant relationship even when none exists. Just think about that for a second. Two totally unrelated things, like the stock price of some tech company and, the number of lawyers in California, can look powerfully connected just because they both happen to be drifting upwards over time. It's the ultimate statistical illusion.
So how do we, as data detectives, catch this thing before it completely wrecks our work? Well, we need the right set of tools to test for it. And here is our primary toolkit. We've got tests like the Augmented Dickey-Fuller, or ADF, and the Phillips-Perrin test, or PP. Then there's another one called the KPSS test. Now look closely at the table and notice the absolutely crucial difference here. What they assume to be true by default, their null hypothesis.
This right here is probably the most important concept to get your head around. These two groups of tests are asking fundamentally different questions. It's kind of like one detective asking, is there evidence this person is innocent? While another detective asks, is there evidence this person is guilty? Totally different starting points.
And this illustrates that difference perfectly. The ADF and PP tests start by assuming your data is guilty, that it has a unit root. You need really strong evidence to prove it innocent, to prove it's stationary. The KPSS test? It does the exact opposite. It assumes your data is innocent, that it's stationary, and you need strong evidence to prove it's guilty of having a unit root. Honestly, using both types of tests is the smartest way to go.
It gives you a much more complete picture. But what happens when our data has these repeating cycles? Like retail sales that always peak in the winter. Well, this introduces a much more complex and much trickier kind of culprit.
This is what we call a seasonal unit root. The basic problem is exactly the same. Shocks become permanent. But in this case, the shock is tied to the season itself. So imagine a huge supply chain disruption one holiday season. A seasonal unit root means that disruption doesn't just mess up that one year, it could permanently throw off the pattern for every single holiday season from then on.
And here's the catch. Our standard detective tools, the ADF and PP tests, they can't find the specialized culprit. They're just not built for it. They're only designed to look for that general, non-seasonal kind of wandering.
For a seasonal culprit, you need a specialized tool. The most common one is called the Heggie test. Now, you don't need to memorize the name. Just know that specific tools exist to hunt for these seasonal ghosts. That completes our detective's toolkit.
So the next time you see a trend in your data, you have to ask yourself, is this a real story, or is it just the statistical ghost leading me astray? Knowing how to hunt for a unit root is the difference between finding genuine insight and being completely fooled.